Hi, I'm Rachel Hilla.
And I'm Maisha Rahman, and today we're going to explain how to add vectors using the component method in Precalculus.
Adding vectors has many real-life applications. You can use them to figure out the force and/or velocity of something, or use them to figure out what direction you need something to go.
For example, vectors can also simply be used to figure out how hard and at what angle you need to hit a golf ball based on the force and direction of the wind.
Before we do any examples, let's go over how to find the magnitude and direction of a vector.
To find the horizontal component or the x component of a vector, use the magnitude times the cosine of the angle between the vector and the horizontal.
Similarly, to find the vertical component or the y component, you would use the magnitude times the sine of the angle between the horizontal and resultant.
Once you have the horizontal and vertical components, you can use them to find the magnitude. To do this, you take the square root of the absolute value of x squared plus the absolute value of y squared, which results in the final magnitude.
So the direction of a vector is the angle between the vector and the x-axis.
To solve for this angle, you would start off by using the equation tangent of theta equals sine over cosine.
You would then rearrange the equation to solve for theta, which would be theta equals arctangent or inverse tangent of sine over cosine, which is the same thing as theta equals arctangent of y over x.
So let's start off by doing an example. The first thing we would do is figure out the horizontal and vertical components of vector A. In this case, it would be 5 cosine 20 and 5 sine of 20. Then you do the same thing for vector B, which gives you 5 cosine 225 and 5 sine 225.
And then, since we have two vectors, we would need to add both components to get the final components of the resulting vector. So our final horizontal component would be 3.4 inches, and the vertical component would be negative 3.12 inches. And to find the magnitude, we would do the square root of 3.40 squared plus 3.12 squared, which would give us 4.161 inches.
To find the direction, you would take the inverse tangent of sine over cosine, which is negative 3.12 over 3.4 inches, and that gives us negative 42.54 degrees, or 317.46 degrees standard trig.
Let's do another example. A soccer player kicks a ball to another player on the field by a distance of 4.5 meters at 60 degrees north of east. The wind travels at a rate of 8 meters per second, 45 degrees north of west. Figure out where the soccer ball ends up by finding the magnitude and direction.
For vector A, the horizontal and vertical components would be 4.5 cosine 60 and 4.5 sine of 60. For vector B, the horizontal and vertical components would be 8 cosine 225 and 8 sine 225.
Once again, we would have to add these up. So our final horizontal component would be negative 3.40 meters, and our vertical component would be 9.55 meters. So to find the magnitude, we would do the square root of 3.40 squared plus 9.55 squared, which gives us 10.14 meters.
Then to find the direction, you would take the inverse tangent of 9.55 meters over negative 3.40 meters, which gives us negative 70.40 degrees. But since this is in the second quadrant, you would minus 70.40 from 90 and then add 90 to that answer, which gives us 109.6 degrees standard trig.
Now let's do a problem that has more than two vectors. Once again, we would need to find the horizontal and vertical components for each vector. Vector A would be 8 cosine of 270 degrees and 8 sine of 270 degrees. Vector B would be 15 cosine of 60 degrees and 15 sine of 60 degrees. Vector C would be 12 cosine of 205 degrees and 12 sine of 205 degrees. And then vector D would be 10 cosine of 143 degrees and 10 sine of 143 degrees.
When you add these vectors together, you get negative 11.4 meters for cosine and 5.94 meters for sine. Then to find the magnitude, you take the square root of 11.4 squared plus 5.94 squared, which gives us 12.82 meters.
And to find the direction, we would do the inverse tangent of 5.94 over negative 11.4, which would give us negative 27.6 degrees. But once again, since our final results will be in the second quadrant, we would subtract 27.6 from 90 and then add 90 back to give 152.4 degrees standard trig for our final angle. Thanks
Thanks
for
for
watching.
watching.